Hello everyone, welcome to 1000 Math 7. This is the fifth video or part 5 of the first chapter sets, and this will be the last lecture video or theory video of the first chapter of class 11 maths. Alright, the topic that we will discuss today is complement of a set. Okay, complement of a set. So this is the last topic that we need to discuss. So all of you know that whenever you have a set, you will have some elements in it unless it's a null set, right? Because null set will have no elements in it. And whenever you have a set, you can think of a universal set for that set, right? Like let's say for example you have a set A, okay? And A is a set of the first 10 natural numbers. So what will be A in the roster form? It will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So A is a set of first 10 natural numbers. Now for this set A, you can think of a universal set, right? And we can say that the set of all natural numbers will behave as a universal set for this set A. So I can write the universal set for this set A as what? The set of all natural numbers, that is 1, 2, 3, 4, 5 and so on. Okay. Now if you look carefully, the set A has what? 10 elements in it. And the universal set has infinite number of elements. We can keep on writing as long as we want to. But the 10 elements that is present in the set A, okay, is also present in the universal set, and the universal set has some extra elements too, like 11, 12, from 11 then 12 then 13 and so on are the extra elements that is present only in the universal set, right? So the collection of this extra elements, okay, that is present in the universal set when compared to this set A, the collection of these extra elements is known as the complement of A. Okay, so it is denoted as, okay, complement of A, okay, is denoted as A dash. So just add a dash to it. So what is A dash? A dash is the collection of all the elements that is not present in the set A but is present in the universal set for this set A. So it will be what? 11, 12, 13, 14 and so on. Okay, and A dash is the what? This set, okay, this collection of numbers or this set is the complement set, or you can say A dash is the complement of set A. So always remember, whenever we say complement of sets, let's say of the set A, okay, of the set A, then complement of A is denoted by A dash. If it's B, then it will be denoted by B dash, and this A dash is a set of what? Set of all the elements that is not present in the set A when we compare it with the universal set. Or you can say, whenever you are supposed to find the complement of a set, okay, make sure to think of a universal set first and then compare both the sets, okay, compare both the sets and check the elements that is not present in the set A, and whatever is not present in the set A when compared to the universal set, those elements will be called as, the collection of those elements will be called as the complement of A. Okay, so always keep in mind to think of a universal set in case of complement of a set. Now if we try to think in terms of Venn diagrams, okay, then the Venn diagram for set A is what? Draw a circle, name it as A, and write all the elements inside it, right? 6, 7, 8, 9, 10. Okay, so this is the Venn diagram for the set A. And along with the universal set, now if we want to draw the universal set along with the set A, then what will you do? You'll draw a rectangle first. This is the universal set, which is a set of all the natural numbers, and you have the set A, which is a set of first 10 natural numbers, 6, 7, 8, 9, 10, right? So this empty space, okay, this empty space outside the set A is the complement. Like whatever element will lie here, the collection of those elements will be the complement set. Okay, so it's obvious, right? A dash, okay, A dash or the complement of A will have all the elements that A does not have, and it purely belongs to the universal set, right? Here 11, 12, 13, it purely belongs to what? To the universal set, right? And in terms of difference of sets, okay, how can we write the complement? A dash is equal to what? U minus A. See, A dash is what? Is a set of, A dash is a set of all elements that purely belongs to U and not to the set A. So here I have told you that this is the region which is A dash, or the complement of A, means all the elements that lie in this region will purely belong to what? U, and not to the set A. Okay, so this is it. This is the whole idea of complement of set. So always remember to think of a universal set whenever you need to find complement. Okay, all right, now let us go ahead and note down some important properties. Okay, there are some properties of set of this complement that is very important for all of you to know. So the first property is A union A dash is equal to U, and A intersection A dash is equal to phi. Means if you find the intersection of A and the complement of A, okay, then you will get a null set, and the union will give you a universal set. Let's see how. Okay, so let's say you have a set A, okay, and there is a universal set for this set A. Now this is a universal set, and this is a set A. Now this region, inside region is A, right? Whatever element is present inside this circle is what? It belongs to the set A, and outside region is what? A dash, right? This region is A dash. So when you combine this region and the rest of the region, it will form the complete universal set, right? So union of A and A dash will give you a universal set. Okay, and the intersection, let's see, is there anything common between what is present in this circle and what is present outside the circle? There is nothing common, right? In this case 11, 12, 13, 14 and all those numbers are present here, but 1 till 10 is only present here. So if you try to find the common elements between this and this, it will give you what? Between this and this there will be nothing common, right? So that's why you get a phi or a null set. Means this is a different set, and the outside or the complement is also a different set. So these two are the complement laws. Okay, complement laws. I am showing it in terms of Venn diagrams so that it's obvious to you guys. Okay, now this one is important. Okay, A union B dash means you do A union B, means you have two sets, okay, like this, two sets A union B you do, and you find the complement. Okay, so when you do A union B, it means both the circles covered, right? All of the part is covered, and complement of this means the outside part. Now you look beyond this circle, so the outside part, right? So this is equal to A dash A intersection B dash. Okay, you can prove this by the Venn diagrams only, and the other law is A intersection B dash is equal to A dash union B dash. You can remember it in this way. Okay, union becomes in intersection, and the complement gets broken down to A and B, both of them. If it's intersection here together complement, it means intersection will become union, and the complement will go to each of A and B. Okay, this is known as DeMorgan's law. DeMorgan's law. So I'll prove this by Venn diagrams, but make sure to note it down as of now. Now the third one is A dash means one time complement, and when you do the complement once again, okay, you'll get back A itself. Now how can you prove this? Just see here. Okay, if this is A, this is the universal set, then A dash means what? The outside part, right? Only the outside part, not the circle. Like whatever is inside the circle will not be included. When you do the complement once again of the outside part, it will be just the inside part, means A. Okay, so double complement. This is what? Double complementation law. You don't need to remember the name of this. Okay, it is logically right. You do the complement twice, you get the same set back once again. Okay, and the last one is U dash is what? Phi. Obviously, if you talk about this U, complement of this U is nothing. Okay, so it's phi, and phi dash. Okay, complement of nothing is what? A. Okay, I think this is U. Okay, U. So this is what? Law of empty set. Okay, law of empty set, and this is law of, or this is law of empty set. Okay, this is law of empty set, and this is the law of what? Universal set. Okay, universal set. All right, I was supposed to show you this, right? Let me show you this one. Now the DeMorgan's law. Okay, why I'm showing you this? Because this is important for all of you to know. DeMorgan's law. there was a person named Morgan, D. Morgan, so after his name this has been given. So the first law is A union B complement, okay, will be A complement intersection B complement, means union will become this, and the other one is A intersection B complement will give you A complement union B complement. Now if you think in terms of Venn diagrams, okay, let there be two sets A and B. So when you combine both the sets A and B, let's say in this way, and there is a universal set for both the sets A and B, okay, then this is the universal set. Now think the left hand side, okay, the left hand side is what? A union B, and then do a complement. So first do A union B, so it will be what? It will be this region, right? Oh, the whole A and B together. So this is A union B. So what will be A union B complement? It will be apart from this A and B, everything else, like this, right? This region, the outside region, will be A union B complement. Okay, so we got to know that the left hand side is the outside region apart from A and B. Now look at this one, okay, A dash intersection B dash. So if you draw A and B separately, okay, this is what A, and if you talk about A dash, then this is the outside region only, right? And you do intersection of B dash. So what is B dash? If this is B, then this is the outside region, that is B dash. This is a universal set, universal set. So intersection of both of this will be what? The same diagram, right? The common region for both of this, the common region is the outside region. So leaving apart A and B, the outside region is the what? A dash intersection B dash, which is same as this diagram, right? The outside region. So this is why they are both equal, okay? And the next one is also, which you can prove by using Venn diagrams, A intersection B dash. So it will give you what? Let there be A and B. This is A and this is B. So this is the common region, right? Intersection B. So when you say A intersection B complement, then it will mean what? All the outside region, this region, right? This whole region, including this part also, okay, not just this part. Leave this part, the common part. Apart from that, everything is what? A intersection B dash. So this is the left hand side, right? We got to know that leaving this part behind, everything else is what? A intersection B complement. Now think of the right hand side, okay? A dash union B dash. So if you do A and B, okay, A dash means what? Leaving apart A, everything else, right? Just leave out A. And when you do B dash, it means what? Leave this B and do everything else, means everything else, okay? Leave this B out. So which region has not been intersected, or which region has been left? This one, right? This common region. So here also the common region was left out and everything else was included. Here also the common region is left out and everything else is included. So this is a proof of DeMorgan's law. Alright, now let's go ahead and do some examples mentioned in your textbook and try to apply whatever we have learned today. Okay. So this is the sheet number 1. Here it says let U be this one. So this is the universal set, okay, that has the first 10 natural numbers, and the set A is what? 1, 3, 5, 7 and 9. Okay, for this set A, this is a universal set because whatever element is present in the set A, okay, 1, 3, 5, 7, 9 is also present in the universal set according to the definition of a universal set, and the universal set has some extra elements too. So we need to find what? Complement, A dash. So what will be A dash? A dash is a collection of all the elements that is not present in the set A and is present in the universal set. So it will be what? 2, 4, 6, 8 and 10, right? Because 1, 3, 5, 7 and 9 is present in the set A, so I cannot include this. Apart from whatever is not present in set A when compared to the universal set will be the complement. Now here it says let U be the universal set of all the students of class 11 of a co-educational school. Means what? A school in which you have both boys and girls together, okay, co-educational. And A be the set of girls in class 11. Find A dash. So in a school, if you have boys and girls, and girls, all the girls together has been called as set A, then what will be A dash? The universal set is your school that has both boys and girls. There is a set A which has just the girls. So A dash will be apart from girls whatever you have. That means boys. So what is A dash? Is the what? You can say X such that X is a boy in the school. Okay, or you can say A dash is a set which is a collection of all the boys, okay, leaving behind the girls. So this is the complement. Now here also let U be 1 2 3 4 5 6. Okay, this is the universal set. There is a set A and there is a set B. So the set A has two elements, 2 and 3. You need to find A dash. So let's try to find A dash. A dash will be what? Elements that is not present in the set A when compared to the universal set. So it will be what? 2 and 3 is present. So I'll not include 2 and 3. I'll include the rest of them. That is 1, 4, 5 and 6. Okay. And B dash, if you try to find, this is B dash. Okay. So if you try to find this, elements that is not present in the set B when compared to the universal set. Okay. That is 1, 2, 3, 4, 5 is there. So I'll write 6 only. Okay. 1, 2 and 6. Now here it says find. I've done this and this. Okay. Now we need to find A dash intersection B dash. Okay. A dash intersection B dash. Now let's first find A dash. I have A dash, right? This is A dash. I have B dash also, right? So try to find intersection of these two sets now. What will be the intersection? Means the common elements. Okay, so 1 is a common element and 6 is a common element. So what can I say? A dash intersection B dash is what? 1 and 6, right? So this is what? This answer. Now show that this is equal to this. Means I've done the right hand side. See, this is same as this one. So let me do the left hand side here and see if I get 1 and 6 as the elements or not. So the left hand side is A union B dash. Means first we need to do A union B. Okay, let's do this. A and B together, unite them. Okay, it will be what? 2, 3, 4 and 5, right? 2, 3 are the elements of set A, 3 is the element of set B, and 4 and 5 also. So now if you try to do the complement of this, I've done A union B only. Now let's do the complement. Complement with respect to the universal set. So it will be what? All the elements that is not present in this set. That is 1 and 6, right? So this is what? A union B dash is this. Now the left hand side, okay, the left hand side, this is the left hand side, this is the right hand side. So the left hand side is what? 1 and 6. Right hand side is also 1 and 6. Hence we have proved that left hand side is equal to right hand side. Okay, so this is it for today. I hope that each of you have understood what is complement of a set and some of its properties. Okay, do make sure to remember the properties, and thank you so much for watching this lecture. We'll see you in the next video. Thank you.